Good everyone and welcome to another problem solving session with Special Maths Academy. We'll be discussing the next geometry problem in the series. That's the NMC first round Olympiad for senior maths 2020. Let D1, D2, and D3 be three parallel chords of a circle on the same side of the center. The distance between D1 and D2 is same as the distance between D2 and D3. The lengths of the chords are 16, 12, and 4. So now we want to find the radius of the circle. Okay, and as you can see, I added a red option to C here because I believe there was a typographical error in the problem. It should be 297 here rather than 293. But then let's see how I arrived at 297. Okay. So to solve this question, we as usual draw diagram. Okay. So let's say this is the center. We're going to be using the fact that the perpendicular bisector of every chord passes through the center of the circle. Okay. So it means if these are chords that are parallel, the perpendicular bisectors pass through the center of the circle. Now, since the chords are parallel, it means the perpendicular bisectors of the three chords are same. So, why isn't the fact that any line drawn from the center of a circle to the center of any chord meets it at 90 degrees? Now, since the three chords are parallel, it means that the line drawn from the center of the circle through the midpoint of one of the chord is same line drawn from the center of the circle through the midpoint of another chord. So let me just quickly describe what I'm talking about. So, okay, let me erase this. So let's say two chords are parallel. Okay. Now, we're using the fact that the line drawn from the center of a circle to a chord, the center of a chord meets it at 90 degrees. Okay. So from the center of the circle, we draw a line to the center of the first chord, the midpoint of the first chord. Okay. And we know that this is 90 degrees. So let's say we draw another line to the center of the other chord. Let's say it's a different line and 90 degrees. Now, since these two lines are parallel, it means if we extend this line, so let me just use a different color. Okay, so this is purple. So it means if we extend this line here, since these two lines are parallel, it means this angle here is also going to be 90 degrees. Okay. Now we know that we have something like this. We have a triangle. This angle here is 90 degrees, and this angle here is 90 degrees. Now we know that this angle here, sum of two opposite interior angles gives the exterior angle. So it means this angle here has to be 0 degrees. Okay. So that means that if two chords are parallel, the line drawn from the center of the circle through the midpoint of one of the chords passes through the midpoint of the other. So we use that now. Okay. So let's use that fact now. So basically, you can just learn some ideas of proving some obvious looking things, but in maths we have to be rigorous. We have to make sure that we always have proofs. Okay, so let's go on. So now I'll say this is a circle. I think I must draw a perfect circle. Okay, so and then this is first chord, second, and the third. Okay. So obviously, the closer a chord is to the center, the longer it is. So it means the chord closest to the center will be 16. So let's just draw the radius. So R. And then we draw the perpendicular bisector of each of the chords. So the chords are parallel, so just take note of that. Since this perpendicularity is at the center of each of the chords, it means we can just divide each of the chords by 2, and we have a series of right angle triangles. So let's say the distance from the chord of length 16 to the center is K, and then the other distance is as between D1 and D2 that are equal. Let's call it X and X. Okay. So from the first right angle triangle, we have that R squared by applying Pythagoras theorem. So let's say this is chord 16, this is chord 12, and this is 4. So the midpoint of the chord, so it means we divide the 16 by 2. So we have R squared equals to K squared plus 8 squared. And from the second one, the chord of length 12, we have R squared equals to K plus X squared plus 6 squared. And then from the third one, we have R squared equals to K plus 2X squared plus 2 squared. Okay, and we have to solve this system of equations. Okay, so let's dive straight into this question. So one of the first things we can do is we can just try and take difference of equations and see what we can get. So if you take the difference of the first two equations, we'll have 0, and I'll just use difference of 2 squares to make my life easier. So equals to, so the first bracket we have K minus K plus X into K plus X, and then 64 minus 36, that will give us 28. So this will quickly give us, I'll just take this to the other side. I'm just keeping some steps so as to make the video shorter. You can always pause the video and try to get these things by yourself. Also 28. Okay, and then if we take the difference of the third and the second equation, what do we have? So we have 0 equals to K plus X minus K plus 2X into K plus X plus K plus 2X. And then we have a 36 minus 4, which will just give us 32. Okay, so we can take this to this other side. So we have K minus K will cancel out, and X minus 2X will give us negative X. So when we take it to the other side, we have X into 2K plus 3X equals to 32. Okay, so I'll just come up here and continue what I was doing. So from this first equation, we have X squared plus 2KX equals to 28, and from the other one, we have 3X squared plus 2KX equals to 32. And at this point, we can see that we can eliminate K. So we just take a difference of the equations again. And what do we have? We have 2x squared equals to 4, and quickly solving this, we have that x is equals to root 2. So we have that the distance between the chords, the equal distance between the chords D2 and D3 and D1 and D2 is root 2. Okay, so now next we want to find K. So let's try and find K. And you can solve this in a different way. For instance, you can take the difference between the first and the third, and the difference between the second and the first. By many ways you can do it. And the good thing about it is that you always arrive at the same answer. So that's for you to try and do on your own during your free time. But for us, let's just go on to the next thing to find K, because we need K to find the length of the radius. Okay. So now we can take any of these equations. So let's say we take the first one. So we have x squared plus 2kx equals to 28. So we have 2 plus 2 root 2k equals to 28. And we have, this implies 1 plus root 2k equals to 14. So it implies that k is equal to 13 over root 2. Okay? So now we have r squared. We can find r squared from the first one. Is equals to 13 over root 2 all squared plus 8 squared. So we have r squared equals to 169 over 2 plus this 8 squared is 64, and so we can just quickly do that, change that to 128 over 2. So we have r squared is equal to 297 all over 2. So we have r is equal to the square root of 297 over 2. Okay, and so we have that on one side is the square root of 297 over 2. And in a situation like this, I mean, what I normally try to do in exam is, if at all I meet a question that the answer is not there, I try to read the mind of the examiner, try to understand if there was a typographical error or something like that. And that's it for today. That'll be all for today. So see you guys in the next video.